Yeah, hi all. Very good morning once again. Thanks for joining. Okay, so as part of today's session, so we are going to discuss more about the Postgres engine architecture. So far, we haven't discussed. We just walked through the high level thing. We not yet went to the deep dive about Postgres architecture. So today, we are going to discuss majorly two components. One is the buffer memory components, and one more is data components, means storage components. So we divided the Postgres architecture into four different layers. So one is the authentication layer, one is the connection layer, one is the buffer layer, one is the database engine, means storage layer. So today our main focus will be the will mainly on the buffer side, like a memory structure and the storage structure. This is the major two components we are going to focus as part of architecture today. Architecture, okay. Stop me if you're not understanding. Uh, Other components like authentication, connection, while we are complete the installation, once we accessing the Postgres, the concept, main concept we'll talk at that time. We'll talk more on the security part, all the stuff. As of now, to understand the flow, we are majorly concentrating on the two major components. One is the memory structure, one is the storage, means in the sense of disk. Okay, so this is the major two concepts as part of Postgres architecture. So we are going to majorly today we are going to discuss. See, so far, what we discuss is a high level. We not yet went to the each and everything deep dive. So today, what we are going to discuss is, so when you go to the blogs, okay, when you just when you go and search in the blogs, you will find the like a someone how to explain the Postgres architecture. So you will find lot of the blogs, lot of images. So we pick couple of images, okay, already predefined in the blocks, okay, easily to understand, okay, easily to understand, and we are presenting those images to understand easily. So this is the best image, okay, easiest image whenever you start learning the Postgres architecture. This is the simplest image we are mainly concentrating, but we'll go for little complex image also. Maybe tomorrow we'll go a little complex image to talk more about some more components. As part of today, we are going to focus on the physical files. We are going to focus on the memory, physical memory. Okay, we will concentrate more on the upcoming classes, like authentication methods. Okay, methods will come back in the upcoming classes, along with the connection pools. So how many connections we can establish in terms of Postgres, that stuff will come back in the upcoming sessions. As of now, our main concentrate will be the buffer, okay, along with the physical, nothing but disk. And we'll also discuss about the process, backend process. Is it clear what we are going to discuss today? No? Yes, everyone?
Yes, Sunu.
Yes. Okay, today I'm going to take only 1 hour. Today, tomorrow I will take 1 hour, sir. Okay. Today we are having the SAT deployment. Okay. And 28 or 29 we are going for production deployment as well. Prod deployment, monthly prod deployment. Okay, so for that prod deployment, we are going to do the SAT deployment today. Okay, so complete SAT deploying today. We'll start at 10:30 actually. I'm extending to 11 o'clock. So mostly I will start the SAT deployment at 11 o'clock. So we'll spend for 1 hour. Tomorrow also 1 hour, and going forward again we'll go for the 1.5 hour only. More than 1.5 hour. Okay. And everyone knows that this week in India, one of the great festival, Vinayak Chavithi. Many people are concentrating on that festival as well. Wednesday is our festival, I think so. Okay, so Indian holiday on Wednesday, so we won't take any session on Wednesday. Today, tomorrow we'll complete the architecture. Thursday, Friday we will install the Postgres. Okay, all this week we'll complete the architecture. We'll install the Postgres on Windows. We'll install the Postgres on the Linux server as well. So next week onwards, we'll go for the actual sessions. Now, without any time waste, first let's move on to the architecture. Okay, at least we'll discuss couple of components which are very important to understand. Mostly, I will try to compare with the SQL. Okay, in case if it is similar for Oracle, also you can add on the points. Nothing wrong here. Okay, now so as we discussed last sessions, also there is one called postmaster process. Postmaster is the main process, like our main process which is running whenever we start the Postgres engine. Okay, once we start the engine, Postgres engine, so we have the postmaster process which is running in the background. Under the postmaster process, okay, it's like a parent process which is running in the background. Under the postmaster process, we will start the multiple connections like user 1, user 2, user 3, user 4, the the users which are authenticating to the Postgres. Okay, we have the Postgres process which is running in the background. For every connection there is a process which is running in the background, like like a kind of child. This is our parent process. Postmaster is our parent process, and the child process is Postgres process, which where we are going to establish the connections. Right, for every connection it is running one process. So while we are authenticating, there are a lot of authentication process out there which we are going to implement in the pg underscore hpa.config file, which is more important, where we are going to discuss in the upcoming classes. Okay, once we establish the connection, okay, once we establish the connection, so it will go to the buffer. Okay, once we establish the connection, out of the connection, postmaster process is very important. Postgres process is very important, like a parent and kind of child relationship is there. So while we are installing Postgres engine, I will show you where you can see the postmaster, where we can see the Postgres process, because when we are authenticating, okay, you can easily understand that time. We'll talk that stuff with the practical demo. Don't get confused about where I can see the postmaster, where I can see the Postgres process. Well, once we start the installation on Thursday, we'll complete the installation, right? That once we complete the installation, we'll see the connectivity. When we are seeing the connectivity, we'll talk about the Postgres process, postmaster process, to better understanding purpose. Okay, yeah. Now, once the connection is established, so basically we are going to perform two operations. One is the read, one is the write. Means a business operation. Writes are business operation where we can feel like inserts, update, deletes. Okay, write operation, inserts, update, deletes. And read is nothing but selecting the data, like a bank statement, credit card statement, electricity bill, water bill. Okay, so those technical will call it the reads. So we should understand both operation in terms of architecture. Okay, how reads are working, how writes are working. As part of today understanding, will mainly focus on the reads. Tomorrow we'll go for writes. Okay, so because reads are little simple to understand, so first you need to understand simple. Tomorrow we'll make little complex, because we are going to perform the writes operation. How? When you are doing the writes, like especially writes means modification, sir. It can be any modification. Writes are nothing but modification. Okay, modification. It can be insert, it can be update, it can be delete, it can be create, it can be alter, it can be drop, it can be truncate, anything. Modification is a modification. Means when you are doing any modification, how engine is processing our data. When you are reading, how our engine is processing the data. Any architecture, if you go for Oracle, SQL, any architecture need to be understand in the two algorithms. One is the read algorithm, one is the write algorithm. So, okay, so that is how we will train for SQL Server. Same way we are training for the Postgres as well. Same way we will train for the MongoDB as well. See, to understand more on architecture, whenever I am reading the data, how my engine is processing in the background. When I'm writing the data, how my engine is processing the data. So both you should understand. Reads are something different, writes are something different. Writes are nothing but you are loading the data. Reads are nothing but you are reading the data. Data is already available in the database. You are reading the data. So how the engine will work when I'm reading the data, how my engine will work when I'm writing the data. Okay, so read, write, both need to be concentrated. Today we are going to, as much we will concentrate today, pending tomorrow we'll complete the architecture. So which is more important concept in terms of any database engine. So in terms of any database engine, we should understand how my engine is processing in the background when I'm reading, when I'm writing. So first, assume you are reading the data. Once the connection is established successfully, your engine is running fine, and your connection is also authenticated. So means you pass the right instance name, right port number, right login name, right password, right authentication. So once your connection is completely established successfully, okay, now how my process is happening, how my engine is processing. So for example, when you are reading the data, okay, when you are reading the data, so mainly in the buffer we are having lot of components. In the buffer we are having lot of components like shade buffers, wall buffers, C-log buffers, memory for locking, like a vacuum, work mem, maintenance mem, temp buffers. So as of now, today we are going to focus these two components majorly, okay, because as I told you right in the previous session also, every component there is a dedicated session where we need to understand. So as of now, we are going to focus only two components. One is the shade buffers, one is the wall buffers. Uh, temp buffers, maintenance, work mem, vacuum. We'll talk in the separate laser. So architecture is not yet completed by today and tomorrow. It will continue overall your training, because every whenever we are discussing certain concept, like for example, we are discussing about vacuum. Okay, again you need to integrate this concept into the architecture only. Okay, that is how architecture will train. Today itself, can you explain all these components, Upumis? Some components can be understandable, some components we can't understand. Okay, that much, because I need to go little more other concepts also, like a parent and child kind of relationships are there. So as of now, today we are going to mainly discuss on the majorly two concepts. One is the shade buffers, one is the wall buffers, one is the C-log buffers. Okay, and we are also going to discuss about the temp buffers also. Okay, so we'll discuss temp buffers. So these are the major concepts we are going to focus today. Now, coming to the shade buffers, when we specially go for the memory in terms of Postgres, okay, in terms of memory, so one is the shade buffers. Okay, in a simple lay terms to understand. Okay, in a simple lay terms to understand. Okay, shade buffers is the more powerful in entire your memory. In entire your memory, shade buffers like nothing but a data. Okay, data buffers. You can call it as a data buffers. Okay, or you can call it as a shade buffers. Shade buffers. See, physically, to understand, our data will be stored in the pages only. Okay, in the Postgres also our data is storing in the form of pages only. Okay, if someone will ask how data is storing, means data is storing in the pages. Okay, for example, you are reading the data. Assume, sir, you are reading the data. You wanted to read employee data. Select star from EMB. Okay, you are reading the data. Data is already in the database. Physical, your data is already in the database. Now you need to read the data, right? Now whenever I'm reading the data, so first we need to understand shade buffers are nothing but data cache. Shade buffers are nothing but data cache. Okay, data cache, where your data is available in terms of cache. See, I can give you a simple example. If you go to the bank, okay, if you go to the bank, there will be main locker. Every bank will hold the main locker, and every you will go to deposit the amount, or you will go to withdraw the amount. So you will go to the main locker, or you will go to the accountant where they are going to place some cash. Where you will go, sir? Where you will go? If you want to withdraw, or if you wanted to deposit, you will go to the accountant. Accountant, there is a separate cabin. You will go to the accountant department, and you will tell them, hey, I need to deposit this much amount. I need to withdraw this much amount, and they will process your with your action. Okay, like same. First, what it will do? Shade buffers are nothing but data cache. Data cache, simple to understand, so don't get confused by namings. Whenever you see the names, you will get confused, but technically speaking, shared buffers are nothing but data cache. Means whenever you try to read the data, whenever you are reading the data, first what it will do, it will go and verify any data is available in the data cache. Currently there are no data. Currently there are no data because you are running first time. I am running first time select star from EMP. So there is nothing called cache. There is nothing data. Now what it will do? Your engine will go to the physical file, get the data, place one copy in the cache, and sends the data to the user. This is what actually the process is. See, whenever there is no data in the data cache, okay, so it will go to the physical database. Means physical means disk, sir. If I'm calling as a physical, you should understand like a disk. It will go to the disk, get the data, place a copy in the shared data cache, and sends the data to the requester. This is what happening in the background. Either you are modifying the data or you are reading the data. So first the data means the pages need to be available in the cache, because memory is a more powerful. You can't make any changes in the physical files directly. You can't make any changes in the physical files. Everything you should do in the cache only. Everything you should do in the cache only. Getting my point, everyone? No? Yes? So shared buffers are nothing but data cache. Data cache. Either you are reading the data, either you are writing the data. First, it will verify any related files are available in the cache or not. If not, get the data from the disk. If yes, process the data from the cache itself. So for example, I am performing select star from EMP. First time it will go to the data cache, means shared buffers. It will verify any pages, any data is available related to this table. If yes, get the data. If no, go to the physical and get the data. Got it? High level? No? Yes? Everyone?
Yes, Sonu.
Okay. Now, see, data cache. Nothing but, sorry, shade buffers. By default, your shade buffer size will be 128 MB. Okay, your shade buffers default value is 128 MB. The default shade buffer value is 120 MB. Now 120 MB is very smaller, right, Subbu? I need to increase how much I can set the for shade buffers. This is also very important, sir. I am not going to discuss now what is the best value you need to prefer, but many experts are saying that out of your RAM, out of your physical RAM, how much physical RAM is allocated for your system, how much physical RAM is allocated for system, out of that 25%, okay, 25% you need to allocate to the shade buffers. Okay, you need to allocate to the shade buffers. 25% you need to allocate to the shade buffers. So can I get the recommendation, Subbu? Yes, I will show you how you can get the where you can get the recommendation also. We'll talk on that much, that much, sir. First, you should understand shade buffers are nothing but data cache, where our data is processing. Where our data is processing, either you are reading the data, either you are writing the data, your data is processing from the shade buffers only. The default value is 128 MB. The best value recommend many experts will recommend is, okay, 25%, greater than 25%, greater than, sir, I mean to say greater than 25% of your physical RAM you need to set to the shade buffers. You need to set to the shade buffers. Is it clear, everyone?
Yes, Sonu.
Yes. Now, what do you mean by wall buffer, Subbu? For example, sir, you are writing the data. Okay, you are writing the data, you are inserting the data or updating the data, deleting the data. So you are inserting, updating, deleting the data. Now mainly, okay, mainly everything inserts, update, deletes, and along with the reads will process in the your shared buffers only. So shared buffers is the more powerful in entire your memory engine. In entire your memory engine, shared buffers are more powerful component. Powerful component. Now, for example, you are writing the data. Okay, writing the data. You are modifying the data. Okay, whatever you are doing modification, whatever you are doing modification, that need to go to the physical. That need to sorry Okay, that need to go to the physical. How you are going moving to the physical, all the stuff we'll discuss. Sir. Now, for example, you are doing some modification. Okay, either insert or update or delete. You are doing modification. Now, what will happen when you are doing modification means, okay, whatever you are doing modification, okay, whatever you are doing modification, parallelly it is moving to the wall buffers. Nothing but log. Wall buffers is nothing but log cache. Okay, wall stands for write ahead logging. Write ahead logging. Wall stands for write ahead logging. Means whatever you are making changes, all the changes before it go to the data, every change need to make entry in the wall. Okay, need to make entry in the wall. Okay, I think I'm not sure about Oracle. The SQL people can understand because this is how we'll train. Okay, whatever the changes you are making all the changes before it directly go to the physical, every change need to go to the log. So write ahead log is nothing but like a log cache, sir. Log cache for better you are under, but don't tell log cache data cache to the interviewer. Okay, please, sir, this is for your understanding. Again, I'm repeating, this is for your understanding. Okay, when you are while you are explaining to the interviewer, you need to explain the shade buffers, wall buffers, C-log buffers only. But to understand little deeper, easiest way, I am explaining in the different ways, sir. Wall buffers, technically you can call it as a log cache. Log cache. Every change whatever you are doing, before it go to the data file, every change need to go to the wall. Wall is nothing but log cache, write ahead logging. Why, Subbu? Why, Subbu? As a DBA, everyone must and should know about acid properties, right? Everyone. Atomicity, consistency, isolation, durability. To fulfill the durability, sir, there is a concept called D. D stands for durability. Okay? D stands for durability. Means cache, see, D stands for durability. Basically, every change, whatever we are making, every change need to go to the wall. Need to go to the wall. That is how the engines are designed. Basically, that is how the engine is designed. Means whatever the change you are making, those changes will go to the wall buffers. From wall buffers to wall files. Wall buffers to wall files. Wall buffers to wall files. Data cache means shade buffers to data files. So there is a mapping, sir. So don't get confused. In the RAM, you are calling as a shade buffers. In the physical, you are calling as a data files. In the RAM, you are calling as a wall buffers. In the physical, you are calling as a wall files, wall archiving files. Wall files, wall archiving files. Okay, wall files, wall archiving files. So wall files are nothing but a log files. Every change, whatever you are doing, all the change must and should go to the wall buffers. How these are moving, Subbu? That is the next question. Definitely, many people will ask. But before that, is it clear, everyone? No. Yes. We'll talk, sir, about data files, wall files, all that stuff. First, focus on these two. It's like a data cache. It's like a log cache. Is it clear about these two components?
Yes, sir.
Yes. Okay. Good, sir. Now, see. Now there is one more component called C log, sir. Committed log. Okay. So, see, users are performing inserts, update, deletes. There are. I'm not sure about how many. how many types of transactions will perform, sir? Is there any idea, anyone? How many types of transactions will perform? How many transactions are there? How many types of transaction?
DML, DCL.
Not that level.
Implicit
Anyone
and
knows?
explicit.
Yeah, good, sir. Hari, right? Yeah, good. Implicit transaction, explicit transaction. Like a auto commit, okay, automatic commit, and you will perform the commit button, right? Like there is a two types of transaction: implicit transaction, explicit transaction. So in this batch, I'm going to add on that concept also, sir, to show you little practical demo how we will train for SQL. Same way we will train for the Postgres also, like how that implicit transactions are working, how explicit transactions are working, what do you mean by auto commit, what do you mean by explicit commit, okay? So we should understand that algorithm, sir. Okay, so basically, if you are performing insert DML, everyone knows about DML, sir. Anyhow, we will talk about DML also in the upcoming classes. Again, sir, I told you, right? First 10 sessions are very important. Please, if anyone having doubts, also hold for, don't think high level. First 10 sessions are very important because we will discuss much more technical internal stuff, okay? Much more architectures only. First 10 sessions. Inserts, updates, deletes. Okay, these are all auto commit. Auto commit. Okay, inserts, update, deletes are auto commits. Sir, uh, 1 second. 1 second, sir. Slowly. Okay. It's not for. It's for. Okay. Yeah. See, when you are performing insert, update, delete. Okay. When you are performing insert, update, delete, these are implicit transactions. That means automatically commit. Automatically commits. Okay, auto commits. These are implicit transactions. Automatically it will commit the data. But same insert, same update, same delete. Okay, same insert, update, delete. When you are writing in begin tran and n, in between begin and end. Okay, you are writing insert or update or delete. This technically we'll call it as a explicit transaction. Explicit transaction means we should commit the data. We should commit the data. We should commit the data. Please, little better understanding, sir. When we are passing in the between begin tran and end transaction, this will falls under explicit transaction. When you are directly inserting, updating, deleting, it will falls under auto commit. Means automatically it will commit the data. Automatically it will commit the data. To get the commit transaction information, there is a buffer called CLOG buffer. Means whenever data is committing, whenever data see, especially committed data will go to the MDF files. Means come on, data file. Sorry, I'm taking back. It will go to the data file. There is no concept called MDF files. I'm sorry, I'm taking back. Okay, whenever the committing data, everything going into the data files, right? So same information it is writing into the CLOG buffer. Same information it is writing into the CLOG buffer. The number of transaction has been committed. The number of transaction has been rolled back. The number of transaction has been committed. The number of transaction has been rolled back. If you wanted to get that sort of information, we will go and read the CLOG buffer. We will go and read the CLOG buffer. I hope you are getting my point, everyone. No? Yes?
Yes.
Subbu, can you repeat one more time?
See, if you wanted to get how many transactions have been committed, if you wanted to get how many transactions have been rolled back, see, you are performing insert, update, delete, and you can also trigger the rollback, right, sir? Rollback.
Yes.
There is two buttons, commit button and rollback button. So when we are discussing development sessions, sir, I will talk about this, what is commit, what is rollback, what is grant, what is deny. We'll talk, sir. Okay. There is a dedicated session on development. See, the people who are starting directly on the Postgres, it's very difficult to understand what is commit, what is rollback. So I don't know about what is commit, what is rollback. For them, I'm going to take one session on the development, sir. Like a tables, views, stored procedure, functions, triggers, the functionality. I'm not discussing deeper about troubleshooting, but I will discuss about the functionality. When I'm discussing functionality, I will talk about commit and rollback, that stuff. Okay. Is it clear, everyone? Now, so if you wanted to get the committed information, uncommitted rollback information, we will go and read the C-log buffers. Usually we won't go, sir. Usually we won't go until unless there is some junk data is entered into the database. Means what do you mean by junk data, Subbu? Again, for example, users are entering some duplicate data unnecessarily by mistakenly they entered some duplicate data. Okay, they entered some duplicate data. They don't want the duplicate data. Can I get that information? Yes. Whatever junk data, whatever duplicate data, whatever committed data, rollback data, we can go and read the C-log buffers. We can get the C-log buffers. So committed logs are C-log buffers are the committed log buffer. Committed data will be you can find in the C-log buffers. Okay. In terms of asset properties, I is very important, sir. Okay, I is very important, like isolation. Okay, I is very important, isolation. When I'm talking about isolation, we'll talk about the logs. When I'm talking about isolation level, we'll talk about the logs. Logs are very important. Okay, logs are very important. This is very, very important. Logs are very important. When I'm specially talking about isolation level, we'll talk about the locking, blocking, deadlocks, all the stuff. Locking, blocking, and deadlock, all the stuff. So no worries about the locking as of now, sir. Okay, we need to focus on the shade buffers. By default is 128 KB. Okay, so you can set maximum 25 greater than or equal to 25%. Shade buffers are more powerful because your data is processing from the shade buffers only. Okay, before it move to the data files, every log it registered into the wall files. Okay, every log will be registered in the wall files. The default value is like 30 1/3, sir. 1/3, 1/4 of your shade buffers will set like a wall buffers. In terms of like 64 KB. So 64 KB is fine wall log buffers. Okay, 64 KB.
KB or MB?
KB. It's KB, sir. It's not like it's all our KBs only. It's not like okay. Now, when I go to the segments, there is a concept called segments. Again, wall buffers. There is again wall segments. There is a concept called segments. When you go for segments, we can set like a 16 MB wall segments. So again, that's what, sir. Today itself, your architecture is not completed. Please, sir, again, try to understand. Today itself, it's not completed because every component we need to go for practical. So PostgreSQL is not very complex like Oracle or SQL. Okay, it's very easy. If you understand PostgreSQL.config, hp.config, wall buffers, vacuum. Okay, 50 to 60% you are good, sir. Rest only you need to learn. Basically, these are very powerful concepts. So we'll talk about again wall concept separately. Okay, when I'm talking about wall, I will talk. I need to show you the wall buffers, wall segments, wall files, wall archiving, how to enable, how to configure, what are the best practices you need to follow. As of now, the architecture shade buffers are nothing but a cache where the process is rendering everything from the shade buffers. Whatever the modification you are doing before it go to the data files, everything will go to the wall buffers. Okay, wall buffers, and whatever the data which is committing, rollbacking, everything registered in the C-log buffers. Is it clear, everyone? No, yes. No, yes, everyone. Yes.
Subbu, just a question on the C-log buffers. So
Yes.
CLog buffer will have both explicit and implicit transactions data, right?
It's not like implicit, explicit, sir. It's like a committed data, rollback data.
Yeah,
Only
yeah.
that.
By default, you said like an insert update. By default, it will be
Oh, yes.
committed, auto
Yes.
committed, right?
If
So
it is
the data
committing,
also
it
will
will
be there.
register.
Yeah.
Yes.
So
Yes.
this insert update is auto commit. That data will be available. And also, you will have a begin try and an end. So between whatever the transactions you perform, once you commit that, that also will be available in the CLog buffer. You need to say.
Yes, sir. Information, not data.
Mhm.
Don't get confused.
Okay.
No data.
Yeah.
Data will be in the shade buffers only. Shade
Okay.
buffer. Okay. 1 second, sir. Okay. Yeah. Sorry. So data, your data will be in the shade buffers only, sir. Whatever you are rendering, everything you will do in the shade buffers only.
When you say
Okay.
information, is it metadata
Reading,
about
writing.
the,
Reading,
yeah,
writing. Reads, writes. Whatever the files you are creating in the physical, right? Those
Mhm.
files will be copied into shade buffers only. And you will do modification and you will do read. Both you will do from the data cache only, sir, like a shade buffers
But you mentioned
only.
information available in the CLog buffers, right? So what is that
CLog buffer
information?
contains information like how many transactions has been committed, who performed
Okay.
that commit, okay, when the commit has been occurred, that information, right?
Oh, okay.
See,
Got it.
information is
Not actual
something
data.
different.
Mm.
No actual data, no information. Yeah.
Okay. It's kind of a metadata, data about data.
Yes. Exactly.
Oh,
Yes. Yeah.
got it.
Okay. Good, sir. Good about three components, everyone. No. Yes. Good. No. Okay. Now, so temp buffers. Okay. Now we know about we can create the temporary objects. Okay. We can create the temporary objects. So when you are going to create the temporary objects like a temp tables, okay, temp tables, global temporary tables, local temporary tables, and when we are going to create the temporary variables, okay, in the stored procedures, in the ESPs, in the functions, they will create the temp variables. So when you are going to create the temp tables, temporary variables, that will use the temp buffers. That will use the temp buffers. Getting my point, everyone? Okay. So for example, I am not understanding Subbu. See, this is your base table, sir. Okay. To understand, this is our base table where you are having some data. Okay. You want to do some calculations, aggregations, mathematics, all the stuff on the base table. And it is little larger table. You feel that it will impact the performance because many users will access this table to perform the operation. Many users will access this operation to perform on this table, sir. Usually I don't want to disturb this table. What I need to do, I need to copy this table to some other. Okay, then I need to perform calculation, aggregation. Finally, I will load the data. So for that, I am going to create the temp table, temp employee table, and whatever the data in available in the employee table, that I will move into the temp table. Now in this temp table, okay, while it is moving, I will place a lock. After moving, I will release the lock, sir. Now anyone can use this table. Now I will do calculations, aggregations, everything on this table. And finally, if I want, I can move the data to the base table. Got you? No? Understand? High level. I'm not going for deep level. I'm going for high level. So for that purpose, we'll go for the temp. So when you are creating any temp tables, okay, that time, knowingly, unknowingly, your temp buffers are working in the background. Got it? Everyone? No? Yes?
Yes, so I have one question.
Yes.
Likewise, in SQL Server, if we are creating any temp table, it goes to the temp DB.
Here also,
Is
sir, temp files, physically temp files.
okay,
Physically temp files, logically temp buffers. Sir,
okay.
physically temp files,
So
logically,
same
sir,
thing
these
is
are
also
logical, right? These are
Yeah,
logical
so
caches.
same thing is also happen in SQL Server.
Same thing.
Means like temp buffer is
No, no,
also
no. See,
okay.
basically
Okay, got it.
SQL Server having a dedicated database.
Yes,
You
sir.
are creating a dedicated database, sir. And in SQL, you are having a lot of stuff. Okay, it's not that much complicated here. This is not that much complicated when you compare with SQL. So there is a cache, there is a physical. There is a cache, there is a physical. So when you are using temp kind of the stuff, it will use the cache, and finally your data will move into the temp files for until you complete your operation. Until you complete operation, your data will be storing in the logically, means cache, and it is also storing in the physically. Physically, sir.
Okay, you mean to say that after completing the transaction, the data is moved to the temp file,
Yes.
right?
Yes, sir.
Okay,
Yes.
okay, got it. Sir.
Yes. Got it? No? Yes, everyone?
I'm lost, but I'll catch up.
Sorry? Okay. Now, so temp 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 buffers is also very important, sir. Okay. Temp buffers is important. By default, your temp buffer size will be 8 MB. Okay. By default, 8 MB temp buffer size. Okay. Can see you can set the shade buffers, wall buffers, C-log buffers, temp buffers. You can set the memory. That's what. Register all the default values. That what is the best recommended value? We'll talk, sir. We'll talk, okay? Based on your RAM capacity, we'll talk about what is the best value you need to set for shade buffers, wall log buffers, and temp buffers, C-log buffers. You can change these values. So, especially when you are performing any temp kind of stuff, there will be temp buffers are there, and by default 8 MB. By default 8 MB. Now, one of the most important is workmem. Workmem. Okay, workmem means if you are using any order by, for example, you are writing a select statement. Okay, you are writing a select star from EMP. Okay, order by. Okay, order by means when you are when you especially performing sorting, ordering means sorting, ordering. Okay, like a hash functions, hash aggregations, hash functions in the execution plan. When here also, sir, there is a concept called execution plan. In Oracle SQL also there is a concept called execution plan, right? When your execution plan contains the sort, hashing, okay, by default your workmem is working. Okay, in SQL everything is performing in the temp only, sir. I don't know how many people went for our temp DB troubleshooting. Okay, I explain all this stuff. Okay, I'm not including SQL to PostgreSQL, sir. I will talking PostgreSQL only. So when you are using any hash aggregations, hash functions, okay, and the execution plan contains any hash operators, short operators, all will using the workmem in the background. All is using workmem in the background, sir. In the background. Okay, if someone is asking what is workmem, then you can tell when we are using sort operator, hash operators, okay, in the background it is using the workmem. It is using the workmem to sort the data, to hash match the data. It is using the workmem. It is using the workmem. Until 9.3 version, Postgres 9.3 version, 1 MB is the default value. 1 MB is the default value. Okay. From 9.4 version, okay, we are having default value is 4 MB, sir. 4 MB is the default value. 8 MB is the default value. 128 KB is the default value. 64 KB is the default value. Okay, workmem in the sense when you are using ordering, sort by, hashing, all the stuff, knowingly, unknowingly in the background, it is using the workmem. Got it? No? Yes?
Yes, sir.
Okay. Now, last but sir, this vacuum I'm not talking. This is very very important concept. Very very important concept. Okay, I will take a separate session and I will talk it, sir. Now, maintenance workman. Okay, maintenance workman. Okay, what do you mean by maintenance workman? Means when you are performing vacuum, auto vacuum, vacuum full. When you are performing vacuum, and when you are doing any index creation, altering the indexes, and if you're creating the foreign keys, all the stuff, like when you are performing vacuum, indexes, index, okay, when you are rebuilding the index, creating the indexes, creating the foreign keys, by default, it will use the maintenance workman. By default, it will use the maintenance workman, sir. So vacuum analysis, okay, vacuum analysis, analyze, sorry, not analysis, analyze, sorry, I'm taking back, analyze. When you are doing vacuum, when you are doing analyze, means when you are analyzing the execution plan. If you wanted to analyze the execution plan, we will use the analyze concept. Okay, when you are going for vacuum, analyze, alter, create index, alter index, okay, create foreign keys, it is using the maintenance workman. It is using the maintenance workman. Sir, I will back in 2 minutes, sir. Hold on. Yeah, sorry, I'm back. Okay, so yeah, maintenance mem. So this is very important, sir. Basically, when you are vacuuming, when you are creating any indexes, altering any indexes, and when you are creating the foreign keys, all the stuff in the background, it is using the maintenance work name. So when you are using sorting, ordering, hashing, work name is using. When you are using any temp tables, all the stuff, temp buffers are using. Okay, so if you wanted to get the committed data, all the stuff, C-log buffers are working. And whatever you are making the changes, every changes will go to the log buffers, log buffers to the log files it will move. Means wall files it will move. So these are the 6 components you must and should remember when you are especially working with the Postgres architecture in terms of memory. Is it clear, everyone? No? Yes?
Yes, so
No? Got it? Any doubts? Temp buffers?
So,
Yeah,
so
please.
vacuum buffers and memory locks, you will be discussing in our separate session.
Oh, everything we'll discuss separately, sir. Today is just high level. I am passing the
Yeah.
information. Okay. See, that's what I told you, right? Postgres is not complicated like Oracle or SQL. We are having minimal concepts only. If you wanted to become that minimal concept stronger. Okay. Today I just want walk through temp buffers, maintenance work mem, vacuum. There is a dedicated sessions are very important because Postgres will support same VCC architecture. Okay, multi-versioning concurrent control. Okay, so MVCC architecture. When you go for MVCC architecture, only the vacuum will come. For SQL people, it is little confused, but Oracle people you can understand.
Yeah.
Yeah. Okay. These are the 6 components we discuss. I will share the material by evening, sir, today. Okay. Little busy because today I'm having SAT deployment. I will share these 6 concept a material in the sense I will keep in the video description only. Okay, so every video there is a description, sir. I will keep in the video description. Okay, 2 more. Yeah, yes.
Sir, actually, Postgres durations are total how many days?
35 5 days to 40 days. 35 sessions to 45 yeah, 45 sessions, 40 sessions. And 15 to 20 sessions MongoDB. Total 2 months, 2.5 months will take. Sir, so far whatever we done, that is not included. Okay, that is not included. Today, whatever we started today only your batch. So far whatever we discuss 1 or 2 sessions out of that one, that we won't include here. Okay, don't bring. So today we started Postgres architecture. Now onwards will continue. Don't think that okay, Subbu is telling 30 days, 35 days. No, sir. Until whatever we promised we need to deliver, it will continue, sir. Okay. I hope you understand, everyone. Mohammed, right? You asked, right? Yeah. So until whatever we promise, we need to deliver. Don't think that okay, 30 days. Oh my God, 30 days is done. It's very difficult. See, for how we will treat like a SQL also same thing, right? We are telling the same thing SQL like 3 months. Officially, it will be for 3 months. Okay, but 3 months is 90 days only, right, sir? But we took almost 120 greater than 120 sessions only. Almost all are 100 plus sessions only. Like Postgres also same, sir. We are telling the roughly date. Until we'll complete the concept, we won't tell that, oh, your batch is done. Yeah. Mostly, what we are planning is your batch will end by October 31st, sir. October 31st. Okay. October 31st will complete your batch. We are having again 4 to 5 sessions greater only. Yeah. Thank you, sir. Today I'm having sad deployment. Okay. Many people are waiting. Can I continue to tomorrow? Tomorrow we will mainly focus on movement. So today we talk about this one. Tomorrow what we will do? How the data is moving. What is this background process? How data is moving. Tomorrow we'll talk about these two. Now, if you thoroughly understand this one, your Postgres architecture is almost completed, sir. Got it? No? Yes? Everyone? Yep, sir. Thank you. See you tomorrow, sir. Tomorrow
Thank
we'll
you,
spend
sir.
more time because tomorrow I don't have any deployment. Okay. Tomorrow I will complete these two portions, and tomorrow I will walk through little more slides because when you are processing anything, it directly don't go to the shared buffers, right? Definitely, it need to be parser, planner, executor, rewriter. You should understand how the query is processing to the shared buffer that we haven't discussed so far. So tomorrow we'll discuss some more other concepts, then we'll complete the architecture. Means officially we'll complete, but we'll continue in the upcoming classes. Yep. Thank you, sir. See you tomorrow. Tomorrow we'll spend more time. Yep. Thank you.
Thank you so much.
Yeah, thank you, sir.